Okay. Alright, so chemical bond, basic of compound formation, blah blah blah. You can skip everything here. You straight away start here. Straight start from number 6, okay? So when you want to form a chemical bond, right, got two ways. Either you transfer electron or you share electron. Not just any electron, valence electron. Any sort of chemical bond formation confirm in what? Valence electron. So if you are transferring, you are ionic. If you are sharing, you are covalent. Then valence and outermost shell. See, outermost must be completely filled with electrons so that particles in the newly formed compound attain a stable electron arrangement. Tak kisah duplet or octet, janji it is stable. And how to do so? By filling up the shell. So if you got one shell, then it's duplet. Two shell and above is all octet already, as usual. Okay, so we move on. Okay, ionic bond. Anything. Okay, so ionic bond, right? I want you all can skip this. Okay, the only thing I want you all to focus on straight away is the SPM tips. Ionic bond is metal and non-metal. So 1, 2, 3 valence electron means group 1, 12, 13. These are the fellas that donate. These are the cations, positive, okay? All metal, always positive. Now we look 16, 17, sometimes even 15. 15 is your nitrogen, lah. 16 is oxygen, sulfur. 17 is all the halogens, okay? These are the ones who are electronegative. They are very rich with electrons, so they will accept the electron, okay? Now, non-metal atom, group 14, 15, okay? They tend to share electrons in covalent bonds. Okay, nitrogen is a bit of an interesting case, Nitrogen can share, nitrogen can receive, mana-mana pun boleh lah, okay? But carbon memang share. So they will share electrons in covalent bonds. The completely filled outermost shell requires less energy than losing or gaining. Remember, sharing requires less energy than losing or gaining, okay? Why am I reading so fast? Because later down here, we memang going to go in detail about ionic covalent. So this one we don't need to worry so much. Okay, see, this is a covalent bond, this is sharing. Sharing, the diagram looks something like this. For donating, you draw bracket, and then positive, bracket, and then negative, macam tu. See, this is the ion being donated. You can find it over here in the anion, in the halogen basically. Okay. Anything else? This is a form of sharing. This one is also another form of sharing. So you see, this is how you draw the diagram in the end. Okay, I'm just going to go very quickly. Ionic bond. Okay, from here I will start to be more detailed a bit. This is definition. Please memorize. Form when metal atom transfers its valence electrons to non-metal atom. Okay, that's the definition. Now, formation of cation, meaning positive ion. I told you what? Group 1 to group 13. Meaning your alkali metal, alkali earth metal, transition elements, and your group 13, your aluminium, they all donate their valence electrons to achieve duplet or octet arrangement. Duplet only got one fellow can do this, which is lithium. Because lithium is the only metal which is 2, 1. Every other metal is way more. So, now look, it's easier for metal, blah, blah, blah. I want you all to directly focus here. This is what we call a half equation. Okay, it shows us that our metal atom, okay, our metal atom has donated a certain number of electrons and now has a certain ionic charge. So it's from atom to ion with free electron. Here, it's from atom to free electron, then become anion. This is your anion formation, okay? And this is the half equation of an anion. Please remember that. Okay, formation of sodium ion, okay? I want you all to ignore these equations. They're not that important, because the equation is just concept which I taught you all before. Like when the charge become -1, when the charge become +1, I taught you all that already. Okay, these are half equations, okay? Look, sodium atom becomes a sodium ion upon donating its electron. Fluorine atom receives the electron from sodium and becomes a fluoride ion. Fluoride, sodium, you get sodium, fluoride. Okay, ionic bond. Magnesium and oxide, same thing. Butchers and needy, okay? Aluminium and chloride, again, butchers and needy. It's all the same concept, lah. Okay? Now, I'll go ahead and explain this to you, okay? Figure 5 shows the electron arrangement of anion P2 minus, 2 minus. So what we have over here is an anion, okay? And the charge is -2. So if the charge is -2, I get octet. Meaning, if the charge is neutral, I remove 2. So how many electrons are found in the outermost shell of atom? Atom means I remove the 2. So I get 1, 2, 3, 4, 5, 6. Can you all understand? Can you understand means spam? Thumbs up. Okay, cantik. Now this one, look here, positive 1 charge, -2, positive 1 again. So what's going on? Which groups do element Q and R belong to in the periodic table? Very simple. How to find out? Count the charges. So if here is positive 1, okay, meaning this fellow has donated before to achieve octet. So the fellow had 1 outside. Kalau dia ada 1 kat luar, that means what? It's confirmed group 1. Say Q is confirmed group 1. Nothing else is group 1. So automatically you already know your answer is here. Yeah, you can go and find R also, but you don't need to, because it's already very obvious for this question. Okay. Now, this is the most important part. This one read yourself, number 3, okay? This is the most important part. Formation of the bond itself and how to draw it, okay? So, this is your sodium atom, this is your chlorine atom. Draw an arrow here, must draw arrow. Now, this fella here will go here. So sodium in a bracket, your sodium ion must be in a bracket and the charge must be outside the bracket. So same goes for here. Your chloride ion in the bracket, the charge outside the bracket. Then you bring over the sodium punya electron and draw it onto the chloride. Make sure you use X and dot. So this is your X, this is your dot. So when the X goes onto the chloride, which is full of dots, that's how you know an ionic bond has been formed. Okay. These are all the key points. These are all the half equations. Okay, I've already explained everything. This is the theory. Janji you faham this means, then you will be able to score. So there's no need for me to read this out to you, except for this last part, okay? Sodium ion, chloride ion are attracted by strong electrostatic forces. Electrostatic forces forming an ionic bond, okay? So where does electrostatic come from? It comes from here. Look, oppositely charged cations and anions are attracted to each other. Because now your sodium, okay, your sodium is fully positive and your chloride is fully negative. So positive, negative will be attracted to each other like a magnet. So that is where the strong electrostatic forces come from in ionic bonds. Okay, see, this is the one I told you, dot and X, okay? Alright, now magnesium oxide, I don't think I need to explain this either. Because here got 282, so 2 extra, here missing 2. So once this fellow go here, positive 2, this fellow will become negative 2. Well, 2 plus 2 minus lah, to be more precise. Okay, I'm going to skip. Now, steps to deduce the formula of an ionic compound. Okay, this is important, okay? Because sometimes they want you to find the formula, so you got to know how to do it. First of all, you can do it two ways. You can do it the way of the book, or you don't need to read all that and you just understand the way I teach you. Okay, you know me, I'm not going to read unless I really have to. So I'm just going to directly teach you a concept. Because this question, they won't ask you theory. They just want you to draw it out like this only. Okay, so how am I going to form lithium oxide? How? First of all, lithium atom has 3 electrons. 2 will be inside, 1 valence outside. Okay, oxygen has 8 electrons. 2 will be inside, 6. Oops, sorry, I used dot lah. Okay, 6 will be outside. Okay, so now we have an idea that oxygen is missing 2 more. Oxygen is missing 2, but lithium can only give 1. So what we do? We add another lithium, so we get 2 lithium. So 1, 2. So that's how we know, in order to form a bond of lithium oxide, you need 2 lithium and 1 oxygen. Can understand or not, guys? Richard, okay or not, bro?
Yeah, okay, bro.
Okay, then the only other thing you need to focus on is your half equation. Please. This one they like to ask in SPM. They'll ask you for both the half equation, it will be 2 marks. Then after that, they'll ask you to write the whole equation, another 2 marks. So total can come up to 4 marks. Please know how to write your half equations. So your lithium, I told you, maximum the fellow boleh bagi is 1. So positive 1, 1 electron. Oxygen, dia mau 2. So tambah 2, jadi 2 minus. Please, very, very important. Okay, and of course this is the drawing, okay? Put the oxygen in between the 2, like a sandwich like that. Okay, now let's move on to covalent bond. Okay, you guys don't really have to do this. Just do this as your own revision lah. Then if you all don't know, can just send me a message whenever you want. Okay, covalent bond. Okay, non-metal atoms from group 14 to 17 and hydrogen atom. Okay, why hydrogen atom? Because it is the only one that will be like this. Nitrogen going to be negative. Your chlorine going to be negative. Okay, everything is going to be negative over here. Sulfur going to have negative. This one just example lah. I'm not giving the exact charge like 2 minus, 3 minus. I'm just saying these will be negative. Only hydrogen will be positive. But you might be thinking, bro, if hydrogen positive, why is it not counted as a metal? Well, because it's not a metal lah. All metals correct. Group 1, group 2, all the way until group 13. But hydrogen is special a bit. If you look at the periodic table, this will be your table, something like that. You'll have hydrogen there on top on its own. So yes, memang the fellow got 1 electron only. And memang lithium also got 1 valence. But that's the difference. The difference between lithium and why it's a metal. Why is it a metal? Because all metals have at least 2 shells. 1 shell here, 1 shell valence. That's what makes it a metal. Hydrogen is not a metal because it only has 1 shell, which is its only electron. So it is non-metal. Metals, minimum 2 shell. 1 here, and then 1 valence. Ataupun 1 extra after that, okay? So metals are on and on and on. Hydrogen, 1 fleur only. Understand or not, guys? Okay. Now, non-metal atoms, sharing of electrons, okay? So let's go on directly. The new compound form is called a molecule through sharing lah, okay? We look at the formation of hydrogen molecule. They want to achieve duplet. Dorang nak jadi duplet. So how? 1, 1. Share together, they become 2. Okay? I don't think I really need to explain this. And don't worry, in your SPM, they won't ask you to explain like this one. They just want you to focus how to draw. Okay, when it comes to bond formation, they want you to focus on Lewis and this, and then the ionic stuff which I taught you just now lah. They want to focus on that for bonds. Okay. Now, we go on the hydrogen chloride molecule, HCl. Same cerita way. This fellow want to be duplet, this fellow want to be octet. So, the point is they both want to be stable. So, they come together, this fellow will get his duplet, this fellow will get his octet, macam tu. Okay, now, you can draw your Lewis structure either like this or like this. If you ask me, I'd rather draw like this lah. Okay, why? Because this shows that there is a pair of electrons. 1 from hydrogen, 1 from chlorine, together to form a single bond. Okay, so next time when you learn your this one, your carbon compound in the Form 5 syllabus, single bond means 2 electrons, double bond means 4 electrons, and so on and so forth. Okay, so bond refers to the number of electrons being shared. So 1 bond, 2 electrons being shared. Okay, don't need to read explanation. Formation of the double covalent. See, I told you. You see 2 line, 4 electron being shared. You see? Okay, so how to know? This is for carbon dioxide. So the carbon you whack in the middle. Why? Carbon want to achieve octet means the fellow will get 2 from oxygen and 2 from this oxygen. The oxygen want to become octet. It has 6. So it will take 2 from carbon, and this will also 2 from carbon. But the point is, you're not really taking or giving anything. You are sharing. Okay, and that is how you draw the bond. Now, I can sit here all day and explain to you, but this is one of those things where you really need to practice on a pencil, with a pencil and paper, and draw repeatedly again and again and again until you can figure it out. Okay. Now, we look at the formation of a triple covalent bond. Okay, triple covalent bond, same thing. What I told you. If you got 3 line, 6 electron being shared. Okay, I'm not going to explain. It's very straightforward, and I would encourage you all to draw like this. Okay, I'll encourage you all to draw this because it's the same thing you're going to end up doing in your carbon compound for Form 5. Okay, now let's look. Step to determine the formula of a covalent compound. Okay, how to determine? Proton number 6. Do the same thing I told you just now. If carbon is 6, 2 are inside, 4 are outside. And then chlorine 17. 2 are inside, 8 also inside, 7 outside. Okay, I'm just going to draw the 7. So let's think now. For chlorine to be satisfied, it just needs 1 electron. For carbon to be satisfied, it needs 4 electrons. So why not this electron give chlorine, okay? Then get another chlorine, give another electron there. Another chlorine, another electron, another chlorine, another electron. So total we will have 1 carbon, 4 chlorine. So the formula you will get is CCl4. Guys, can you understand or not?
Yeah, I can understand.
Anything blur or not? Anyone blur anywhere?
Okay.
Okay, okay, very good. So this again is like I said, one of those things where I can explain it to you, but you certainly need to pandai practice also lah. Okay, now we move on to the comparison. This is damn important. Can come out in paper 1, can come out in paper 2. Okay, the differences between ionic and covalent. Similarity dulu. Similarity is what? Oops. They both involve valence only. Okay, and their end goal is both duplet or octet. That is the similarity. Differences: ionic bond, metal, non-metal. Okay, transfer of electron from metal to non-metal. Then metal atom loses electron, positively charged ion. Non-metal atom gains electrons, negatively charged ion. Oppositely charged ion, strong electrostatic force. Here pula different cerita. Non-metal, non-metal, sharing of electron between non-metal. Each non-metal contributes electrons without formation of charges. Always remember, guys, molecules are neutral. Okay, molecules are neutral. Do not forget that. Okay, then atoms in a molecule are bonded together by covalent bonds. See, atoms in a molecule. So if I draw CCl4, CCl4. So 1, 2, 3, 4. These are all atoms. They are all bonded by what? All bonded within the molecule by electron. Tetapi molecular forces pun ada. Okay. This one, covalent bond is a form of intramolecular bond. Okay, intramolecular bond. Van der Waals is intermolecular. Intra means within, inter means outside. So if here I got another CCl4, C, 1, 2, 3, 4, there will be forces of attraction here. That is called Van der Waals forces of attraction ataupun intermolecular force. Can understand or not, guys? June. Look, we're already done with covalent as well. Damn fast we are flying. Okay, now I'm going to go to hydrogen bond. Hydrogen bond is damn interesting. Okay, it's line macam a bit in a sense that you can find hydrogen bond intramolecularly and intermolecularly also. Okay, so hydrogen bond, okay, will always be with hydrogen and this plus here ataupun chlorine lah. Okay, HNOF. Always remember that. Hydrogen, nitrogen, oxygen, fluorine. Never forget this. Now, let me explain. Atom, high electronegativity, partial negative charge. Atom, the hydrogen are basically partial positive charge. Why? Because right here, let's say oxygen. This oxygen on its own, this is water molecule by the way, H2O. This oxygen on its own already has 6 electrons. Hydrogen on its own only has 1 electron. Of course, the more electron you have, the more electronegative you are. The less electron you have, the more electropositive you are. So over here, these electrons will migrate towards the oxygen. Don't get me wrong, they're still part of the hydrogen. Okay, they're still part of the hydrogen, but like it's one of those things where the hydrogen says, yeah, I'm bonded to you, but I don't really care. So it's like when you go out for food with your girlfriend, you go eat with your girlfriend, right? Hydrogen is the one that cannot finish the food. So he will buggy very willingly to oxygen. Why? Because hydrogen very small size. Oxygen is the boyfriend. Oxygen is fat. So oxygen is like, damn, you don't want to, okay, I'm going to whack. So oxygen has partial negative. Hydrogen has partial positive. This is called delta, yeah? The sign is a delta sign. So far, are we clear or not, guys?
Yeah, I don't understand, but does that mean that if the hydrogen donates the bond to oxygen, does that mean hydrogen will just disappear or what happens?
Okay, first of all, you use the wrong word. It's not donate, yeah? It's share.
Oh.
So the hydrogen, I want you to think of it like this. Imagine, right, this is a seesaw, okay? Which atom is heavier, chlorine or hydrogen?
Chlorine.
Chlorine. So you can imagine chlorine will be down here and hydrogen will be up here, correct or not?
Yeah.
Okay. Are they connected or not based on the seesaw? Looking at what you see, are the hydrogen and chlorine connected?
Yeah, they're connected because hydrogen got down.
Correct. So the hydrogen and the chlorine will form a bond. Okay. Now, imagine the seesaw has electrons. The electrons is the weight, okay? Electrons is the weight of hydrogen, electron is the weight of chlorine. I want you to imagine, if chlorine is heavier, so the flow got more electrons here, don't you think that the hydrogen punya electron will more likely go down as well?
Yeah.
Now, it's like you're rolling a ball down a hill versus pushing a ball up a hill. Which one is easier? You roll the ball down, correct or not?
Yeah.
Now, did the ball disappear? No. Why? The ball just went to the other side. So to answer your question, they are still bonded. But it's just one side has way more electrons, one side has way less. So when you have way more, you are electronegative. If you have way less, you are electropositive. Is that clear or not now?
Yeah, yeah.
So always remember, they are sharing a bond, they're sharing electrons, and they are still bonded. The hydrogen doesn't disappear, okay?
Yeah, okay, we understand now.
Alright. Manisha, bro? Any question or not?
Nobody.
So that means you had the same question as Richard, but then after I explained, you understand already, lah?
Yeah.
Okay. Now, what we call this is partial positive charge, partial negative charge. Now you might be thinking, bro, I thought you said molecule normally don't have charge. Correct. That's why we call it partial charge. Why? Because this electron still belongs to hydrogen actually. See, this electron here actually still belongs to hydrogen, but the chlorine borrows it so that the chlorine will be happy and the hydrogen will be happy. It still belongs to the hydrogen. Remember, it's not like an ionic bond. Ionic bond is what, guys? Ionic bond is when you donate. So you cannot take it back, okay? You donate. But in a hydrogen bond, you are just borrowing. So the hydrogen is saying like, bro, I'm not using my motorbike anytime soon. You want or not? Then the chlorine is like, okay, can I take from here, pinjam for a while? Then the hydrogen says, okay. So that is why the hydrogen is slightly positive and the chloride is slightly negative. If this was fully negative and this was fully positive, they wouldn't be connected already. Why are they still connected? Why is it partial? Why is it partial? Because there's still a bond. So unequal sharing of electrons, see, creates partial charges at the end of each of the molecule. So the hydrogen end more positive, the oxygen end more negative. So it becomes a polar molecule. Not polar ion, polar molecule. Can understand or not now? Richard, bro, you understand? Okay, chun. Wow, got hard or very romantic. Okay. Alright. Now this is what I want you guys to focus on here. This is what I told you by a intermolecular hydrogen bond. This one is intramolecular covalent bond. See, this is a covalent bond. Covalent because it's sharing electrons. So one more time. When you are actually sharing the electrons, it's covalent. Now, how do I explain this? You imagine that these fellas here are married. Okay, this one all orang kahwin. Okay, I want you to imagine that this one is all orang kahwin, but the problem is right, they very gatal. They go and look at people's wife. See, they all got their own covalent bond here, guys. But they hadap, they want some more. Why? Because in this covalent bond arrangement, you see, the bulk of the electrons is here. So naturally, this side more positive, this side more negative. So this side also more negative, here more positive. So look, there will be polar forces of attraction. Okay, this is intermolecular. So whenever you see a dot macam ni, it is a hydrogen bond. Can you guys understand or not?
Wait, does that mean that the oxygen is connected to the is sharing with 3 hydrogens?
3 hydrogen. Where you see the 3 hydrogen from? I don't see it.
The hydrogen bonds down, the 1 and 2.
Okay, you're talking about this one here, right?
Yeah.
Okay, you look here, by your logic, you are saying that now the oxygen is sharing with 4 hydrogen.
I don't understand this part.
Okay, so to clarify what you said, first of all, what you said is wrong. Keep that in your head, it's wrong. Because the oxygen is, again, let's go back to the husband-wife analogy and then the cuci mata analogy. Husband-wife is oxygen. Oxygen, one husband, got 2 wife. Okay, 2 wife already. Then, he gatal. He gatal why? Because he is electronegative, so he's partial negative. Here, partial positive. Now, since oxygen is partially negative, he gatal. He's attracted to partial positivity. So, even though he got wife already, 2 wife, 1 bond here, 1 wife, 1 bond here, 1 wife. He's sharing the bond. Tapi, this one, this dot here, he's not sharing, but he's just looking from far away. He just cuci mata like that. So, does that mean he formed a bond with hydrogen? No. They don't form a covalent bond. Okay, no covalent bond. They form a hydrogen bond. In a hydrogen bond, right, what matters is charge. Not sharing, only charge. Meaning what? Meaning, in a hydrogen bond, if you are partially negative, you are partially positive, they will be attracted to each other. They are attracted to each other, but they are not together. Another way to explain. This one is a relationship. Okay, look here. This one molecule here, 1 molecule here. We got 2 hydrogen chloride. Okay, we got 2 hydrogen chloride. Look here. If they are like this, they are in a relationship. But even though, okay, if they are like this, they're in a relationship. If they are dotted, situationship. It's like you feel something for each other, but you're not together. Kan? That's a situationship, guys. Come on, like you all just came out of high school. Situationship means what? You like the flirt like you, but you're not together. Correct or not? Exactly. So this is a situationship. This is an actual relationship. So here, all the electrons are still in this relationship. All the electrons are still in this relationship. But because these fellas like each other, they got something going on here. But they are not together. They are attracted together, but they are not together. One more time. They are attracted to one another. Okay, there's an attraction there. Tetapi, because they are in a relationship, all their electrons are being taken up by their current relationship. Richard, is that more clear or not now?
Yeah, I understand now.
Okay, now this is one where you will need to understand the theory. Okay, so this is for hydrogen and oxygen bond. This is hydrogen and fluorine bond. Hydrogen, fluorine, hydrogen chloride, same bond. Okay, hydrogen and nitrogen. So what I told you, the 3 main atoms you need to look out for: N, O, F. Hydrogen bond will go and make bonds. Okay, it will go and form bonds with any molecule that has N inside, O inside, or F inside. Okay, now hydrogen bond is formed partially negative, partially positive hydrogen atom, attracted partially negative oxygen atom of a nearby water molecule. See, like I told you, they're not together, but they are looking at each other because they are attracted to each other. Okay, I'm not going to waste my time explaining this because it's the same theory, guys. The same thing for oxygen, the same thing for fluorine, same thing for nitrogen. I won't explain. Okay, after this, we stop here, then we take a break for a while. Okay, where was I? The effect of hydrogen bond on the physical property of substance. This is important. This is theory. This, they can ask you maybe 2 or 3 mark explanation question in your paper 2. So, most covalent bonds are insoluble in water, low melting boiling point. But covalent molecules such as ammonia, hydrogen fluoride, ethanol show physical properties like ionic compound. Why? Why is their melting point high, boiling point high? And why are they soluble in water? Because they have hydrogen bonds. Okay? Always remember, when there is a hydrogen bond, it acts like an ionic compound a bit. If there is a hydrogen bond, it acts like an ionic compound. Melting boiling point naik, solubility in water pun naik. See, hydrogen bond stronger than van der Waal. Van der Waal is which one? Like I told you all, the CCl4, CCl4, then in between ada van der Waal sikit. Okay, it's not that strong compared to if I give you hydrogen fluoride, hydrogen fluoride, then got hydrogen bonding between the F and the H, ni lagi kuat. Okay, presence of hydrogen bonds. Okay, wait. Presence, hydrogen bond between polar molecules increases melting and boiling point. Why? Because right, it's stronger than Van der Waals. So what do we remember from Form 4 Chapter 2? We remember what? That bila bond lagi kuat, melting point akan naik and more heat energy will be needed to overcome hydrogen bond. Is that more clear or not, guys? Okay, polar versus non-polar, okay? Formation of strong hydrogen bonds, blah, 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 more heat energy required. Then this is non-polar. See, why? Why is it non-polar? This is between H and H only. Tak cukup kuat. You want a kuat hydrogen bond. Kuat means what? H, F, H, and H, O. These are strong when it comes to molecules, okay? Strong molecules. If suddenly hydrogen go play with sulfur ka, hydrogen play with hydrogen ka, hydrogen play with carbon ka, these are weaker a bit, okay? So you look here, hydrogen play with hydrogen, they are not the same molecule. This is one methane, this is one methyl. So this is intermolecular van der Waals forces of attraction. So it is weaker. Always remember, HN, HO, HF, paling kuat. So bond weak, small amount heat energy needed, you will overcome the van der Waals force of attraction and break the bond. Okay, which has the highest boiling point? Okay, which has the highest boiling point? This is how you're going to figure out. How you need to figure out is by drawing the hydrogen bonds between them. So the answer will be D. Okay? Okay, you might be thinking, bro, just now you told me hydrogen chloride. Never not the same as hydrochloric acid. No. Why? Because hydrochloric acid is in the presence of water, guys. Okay, it's in the presence of water. Line cerita a bit. So only methanol can form hydrogen bond between molecules. Therefore, more energy required to break the bond and van der Waals force of attraction. So answer D. Okay, now common molecules such as ammonia, blah 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 blah, dissolve quickly in water at room temperature. Okay, physical property, polar molecule. Okay, let me check. Is there anything I need to explain or not? Okay, so this is hydrogen fluoride. This is water. So it's being surrounded by hydrogen fluoride. This hydrogen fluoride will form hydrogen bond dengan air. Wait, it will form hydrogen bonds with water. How and why? Okay, let me explain. Because water here, this will partial positive, this will partial negative. So they will bond. Now, once they bond via hydrogen bond, okay, see hydrogen bond form between partially positive negatively charged atoms, what will happen? Formation hydrogen bond between these molecules and water molecules replace the hydrogen bonds between water molecules themselves. Okay? So because they form the bond, they will dissolve in water. Now, this is non-polar pula. Non-polar, how are you going to mix with water lah? Hydrogen going to bond with who? Nothing. This whole thing neutral way. So, what happened? Non-polar molecules stick together, form a tight membrane, preventing non-polar from mixing with water. So, cannot form hydrogen bond with water. They are insoluble in water. Okay, roles of hydrogen bonds in daily life. Okay, when your hair is wet, okay, water molecules of that hair may form hydrogen bonds with hair fiber. Why? Because your protein, right? Your hair is keratin. Keratin is protein. This protein got hydrogen inside. Fella will go and cut out the oxygen found in water. So, got hydrogen bonding there. See, hydrogen bonds between water molecules, hair fibers. Cause moistened hair stick together, hard to comb. Dry hair easy to comb. Why? The water already evaporate, so initial hydrogen bonds among protein molecules weaker. Okay, no more water already. What? Then this one, same concept. Wet fingers can prevent the papers from sticking together. Paper sticks to wet fingertips because water molecules create hydrogen bond between cellulose fiber and the paper. Cellulose is hydrogen, so stick to the water molecule fingertip. Dry paper hard to flip because weak van der Waals force of attraction. Okay. Okay, so when you look at dative bond, right? Basically, dative bond, what is it? It's what happens when, let's say you have an oxygen atom to nitrogen atom, you got lone pair of electron here. Okay, these lone pair of electrons will donate it to an ion, for example, hydrogen like that. So this hydrogen, we are not talking about hydrogen atom. Hydrogen atom, we know what? We know that here there will be one electron, but now we're talking about hydrogen ion. Okay, so this hydrogen ion here, if it wants to achieve a stable duplet electron arrangement, it will bind with these two valence electrons, like this. So that's what we call our dative bond. There. These non-bonding electrons are known as lone pair electrons, okay? So see, dative bond is a type of covalent bond in which the shared electron pair comes from a single atom. So if you have a hydrogen ion here, and you have an oxygen atom here, the electron comes just from the oxygen only, like that. So in this case, look, you have NH3, and now what are you going to get? You are going to get NH4+. plus. Change this here, this is not hydroxonium. This one is actually ammonium. Not ammonia, ammonium. And this one is actually NH4+. plus. The book got typo there. Okay, we cancel this off. Now look, this is a normal ammonia atom, ammonia molecule, whereby the nitrogen has 1, 2, 3, 4, 5 electrons. Each of the hydrogen have 1, 1, 1 like that. So they want to achieve duplet, the nitrogen want to achieve octet. So they covalently bond to one another like this. But if you look here, there is a pair of lone electrons, lone pair electrons, okay? These lone pair electrons, what they can do is, they can bind with a hydrogen ion. Ion, not atom, ion. So once it binds with the hydrogen ion, then you look, it will be included like this, and this whole thing now becomes positively charged. Why? Because let's count the actual number of electrons. 1, 2, 3, 4. Then the nitrogen got 5. So 5, 6, 7, 8, 9. But if you look closely, okay, this nitrogen is actually, this hydrogen here is an ion. What? So actually here, no electron. So instead of having 9 electrons, we have 8. So 9 minus 8 is positive 1. Can understand or not?
Yeah, can understand.
Okay, nice. Okay, let's see. I want to see what's important and what isn't. Okay, so actually, all this is supposed to be here. They went at the balikan already. And then all this is supposed to be here. This is actually your water molecule. See, that's your water molecule. Okay, then what? Let's look at the water molecule now pula. One here, one here. Then oxygen has 1, 2, 3, 4, 5, 6. Oxygen wants octet, hydrogen wants duplet. So covalent bond. Now, here we have hydrogen ion. Remember, if this was, let's say, an atom, there'll be 1 electron, okay? So then there'll be 1, 2, then the oxygen 6. See? Look here. Oxygen 6, hydrogen 2. Then oxygen 6, so 8 electron. 9 electron here. Then it will become neutral. But because this is an ion, we only have 8 electron. So 9 minus 8, you get positive 1 here. So these lone pairs of electrons that are not being used will get transferred to the hydrogen ion. Can you understand? Okay. So now we look at the explanation. In water molecule, oxygen, hydrogen atoms achieve octet, duplet electron arrangement respectively. Hydroxonium ion, this is H3O, yeah, typo in the book again. Hydroxonium ion form when water molecule reacts with hydrogen ion. Keyword ion, not atom. 2 lone pairs of electrons on the oxygen atom. Again, another typo. I have no idea why they want to mix it up so badly. In the in the water molecule. This one NH2, sorry, H2O. Okay, then this one does not have any electron in the shell. Lone pair electrons in the water molecule shared with hydrogen ion through formation of dative bond. Okay, then in hydroxonium, atoms have achieved their stable electron arrangements. Okay, now we look at the explanation earlier for ammonium. Okay, so water and hydroxonium sudah settle. Now we settle ammonium. Ammonia, NH3. Okay, nitrogen, hydrogen have achieved octet duplet electron arrangement. Then ammonium ion form when ammonia reacts with hydrogen ion. Lone pair electrons on nitrogen atom. Okay, ion does not have any electron in the shell. So lone pair ammonia shared with hydrogen ion, formation dative bond. Then here, ammonium ion, all atoms achieve stable electron arrangements. So in exam, what are the keywords you need to write? Okay, you need to write this, 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 and this. Same thing here. This one important, then these two important. The middle part, not so important. Can write, but if you don't write also, shouldn't be any problem. Okay, now we look here. Which of the following statement best describes the physical properties of the compound? Okay, now we want to look at the relationship between element P and Q. We count first. P actually berapa? 1, 2, 3, 4, 5 valence. It has 5 valence. Q here 1 valence. Now, from what we can see is 5 valence means confirm not metal. 1 valence, then what you will get? Non-metal plus non-metal. Okay, which describes the best one properly? Okay, which of these statements best describes the physical properties? It should actually be P. Okay, why? Because compound P form is a covalent compound. Now, when it's covalent, right, that means element P relatively higher electronegativity. That's why it's what do you call that? Non-metal. Non-metal always more electronegative. Okay, shared 3 pairs of electrons in the single covalent bond. Q atom partially positive charge. P atom partially negatively charged. So this is a polar molecule, can form hydrogen bonds with water. There's an explanation for this up here if you remember. See, this is the explanation. Ammonia in water. Look, the H can form a bond with the N. Why? Because remember what I told you, HNOF. H can bind with all these 3 via hydrogen bond. Here partial negative, here partial positive. So there is some form of interaction going on. So because of that, you got hydrogen bond between water molecule and ammonia. So it is soluble in water. Got anything you're not clear about or not? Okay, then we go on to metallic bond. Okay, so for metallic bond, okay, metal atoms are arranged closely in an orderly state. Okay, each metal atom donates valence electron, form positively charged ion. Okay, these electrons do not belong to any metal atom anymore. So if you have a lot of sodium here, contoh lah, and all these sodiums donate their electrons. Okay, now the electrons are jumbled already. All of the delocalized valence electrons form what? See, delocalized valence electron freely move around metal structure, forming a sea of electrons. So now, what you need to imagine is these electrons are delocalized, meaning it's no longer like this one stuck to this one, this one stuck to this one. No such thing. They are free to move wherever they want to go already. Okay. Then, now the electrostatic attraction force between positively charged metal ion, C electrons, forms a metallic bond. Okay. So because of the sea of electrons, see, they can conduct electricity. When electricity is applied, electrons that move freely in a metal carry the charges. Electrons move freely, carry charges from negative to positive terminal. Only in 2 states of matter, molten and aqueous. Solid tak boleh. Cannot. Only molten form and aqueous form can. Aqueous means what? Your metal is in water. Like how you have copper solution. Copper sulfate solution dissolved in water like that. Okay. Then, properties of ionic and covalent compounds. This is a whole bug on its own. Alright. So for your Amali, this one, if you have any school teacher, ask them to look at what are the hot topics that usually come out. Because like I said, for me, my goal is I will mainly teach you, what do you call that? Paper 2 and paper 1. So, properties of ionic and covalent, okay? What is the property? The hypothesis is ionic compound, high melting point, boiling point. Covalent, low. Okay? Then we look. Next one. What's the next hypothesis? Ionic compound, dissolve in water, not dissolve in organic. Covalent, terbalik. Do not dissolve in water, dissolve in organic. Okay? Now, this one all, mostly paper 3 only, your Amali. But the theory like this, the hypothesis, you still need to know. Like they ask you which is true or false. Then they will give you a couple of scenarios. Okay, electrical conductivity. Molten state, cannot conduct, solid state. Then covalent, do not conduct electricity in both states. So the thing that allows a metallic compound, what allows metal and ions in general, ionic compounds, to be able to conduct electricity is the theory of C of electrons. Always remember that. Okay, and then this is the type of question they can ask you in paper 1. They will give you this, they will give you this. Then they'll say which of the following theories is true. Then they'll give you here. They'll say that like, oh, covalent compound can conduct electricity, blah, blah, blah. Ionic compound can conduct electricity in solid state. C, ionic compound can only conduct electricity in molten state. D, ionic compound can conduct in molten and aqueous state. So which one is true, then you select D, like that, based on these two photos they can give you. Or they can ask you, okay, between these two, right, which are the two metals? Then here non-metal. Then they'll divide, maybe here lead and chlorine, they say metal. Then maybe here they say metal is lead and magnesium. Then you know that's the answer, then you circle. So these are the type of questions you can expect them to ask in your paper 1. In your paper 2, maybe they'll ask something like theory lah. What state can conduct? Or this one. Why molten state cannot? Because the electrons are not delocalized. Or the melting point, boiling point not met yet. So then the electrons cannot be moving across. Something like that. Okay. Now, this is the main theory lah for hypothesis A, B, and C. Okay. So as you can see here, melting point, boiling point. We look at magnesium chloride crystals. Ionic compounds, okay? They have ionic bonds. They are made of positive and negative ions attracted together by strong electrostatic attraction force. A lot of heat energy needed to overcome forces during melting or boiling. Hence, high melting point, boiling point, non-volatile. Diethyl ether, hexane, covalent compounds formed by covalent bonds. Attracted by weak van der Waals. Little heat energy needed to overcome. And then, low melting, boiling point, volatile. Then here pull up. Same theory again. So now we're talking about solubility, okay? Ionic compound dissolved in water. Water molecule surround positive and negative ions to help separate them from each other. So if we have sodium and chloride, okay, sodium chloride, and we have water, the water molecule will separate them into sodium ion, chloride ion like that, okay? This is due to the polar nature of water molecules. Remember, water is polar, okay? Like this. So here will be partially negative, here will be more partially positive like that, okay? Due to this, they can rip apart the sodium chloride, okay? Partial positive charge, hydrogen atoms, partial negative, oxygen. Partial charges attract oppositely charged ions in the ionic compound. So oxygen will attract sodium, then the hydrogen will attract the chloride. Weakens the strong electrostatic attraction force between ions, causing them to dissociate and form a solution. Okay, then we look at lead-2 bromide pula. Okay, for electrical conductivity now, okay? Lead-2 ions, bromide ions, held together by this, forming, okay, you just need to not do that. Lattice structure, you don't need to know, okay? Ions cannot move freely. Solid does not conduct electricity. This is in solid form. So that's why I told you in solid form, held together by ionic bonds. Molten and aqueous, disrupted by the heat or the water molecules. Okay, molten means you melt it. That one you need heat. Aqueous means you put in water. Allows lead-2 ions, bromide ions become mobile and carry electric charge. So they can conduct electricity. Naphthalene, neutral molecules held together by covalent bonds. They are neutral, so got no electron flow. So do not have free moving ions. Then naphthalene cannot conduct electricity, either solid or liquid states. Okay, now this is the comparison of properties. Okay, this is super duper important. So I've already explained to you all the theory and concept. This one, all of this, must hafal. Okay, so these were the explanations, but this is the actual theory that they will test you in for your paper 2. So I'm going to write here, memorize. I'm going to skip because I already explained it. Okay, now, structure of simple molecule and giant molecules. Let's compare the difference, okay? This is for covalent compounds. Look at what? Look at simple molecule first, okay. Molecular structure, small. Exists, solid, liquid, gas. Chemical bond. Atom held together by strong covalent bond within molecule, weak van der Waals between separate molecule. So this is intermolecular. This one is intramolecular. Melting, boiling, low, because less energy required, overcome van der Waals. And then, what else? What do they have in common pula? What do they all have in common? Both also, don't care you simple or you giant, covalent bond holds you together. Some molecular structure very large, solid state only. Because it's so large, when it's that damn big, right, you're going to need a lot of force to overcome the van der Waals force of attraction and the covalent bond. So you need a lot of heat energy. So because of that, melting boiling point is super duper high, hence why it just exists in solid state only. Because to get that amount of heat is very unrealistic. Then, strong covalent bonds exist within the molecules. No van der Waals attraction forces between molecules due to its giant structure. Then what? High boiling melting point because more heat energy required to overcome the strong covalent bonds. So the bigger the molecule, the stronger the bond. Okay. Now this one is also something you need to memorize. They can ask this in paper 1, like, oh, match the correct ionic compound with the correct use in daily life. Or maybe in paper 2, they'll say list two ionic compounds and their uses in daily life. So it can come out in either one. So you should memorize.